41. Calculate the equilibrium constant at 25 degrees Celsius for each of the following reactions from the value of the delta G notch given. So we have 2 LiO8 solid plus CO2 gas yields Li2CO3 solid plus H2O gas, and this has a delta G value of negative 79 kilojoules, so it's spontaneous. But we're trying to solve for the equilibrium constant. Keep in mind that the equilibrium constant is a capital K value. Now, they didn't say specifically what equilibrium constant we're solving for, whether it's Ka, Kb, right? Just this, K expression for this equation. But it doesn't really matter because there's only one formula that links equilibrium constant to Gibbs free energy, the delta G. 2 variations depending on which variable you're solving for, but since we're solving for equilibrium constant, it's best to memorize the formula as this. Equilibrium constant K equals the E button on the calculator raised to the negative delta G divided by RT. Now let's just go over the variables. I'll start with the R first because that's the constant one. Probably have to memorize that one. 8.314. It's got a few units, joules per mole times Kelvin. These units will dictate what the delta G units should be and the temperature. So, for example, the temperature has to be in Kelvin, but they gave it to us in 25 degrees Celsius. But that's okay, because we can quickly just convert that into Kelvin. Right, Celsius to Kelvin plus 273. More specifically, you'll be adding 273.15. So room temp, 25 degrees Celsius, is 298.15 Kelvin. Now let's work with the delta G value. Joules is in the R units, but they gave me kilojoules here. So I just have to quickly convert kilojoules into joules. But that's okay, right? Kilojoules to joules, I just times by 1,000. So I'm just moving the decimal over 3 times to the right. So this would be negative 79,000. And that's the number that's going all the way over here. Now I have all my variables, so let's just write it out. K equals E raised to the negative, and then I have a big fraction here. The G value was a negative 79,000. And then I have my 2 values on the bottom. So I have the 8.314. 8.314. And then I have the 298.15. Now keep in mind that this is all being raised upward, right? Maybe I'll just drop this negative down. But now I have a negative times a negative. That's a positive, right? The first thing I would do is I would just simplify what this is going on over here. So we have K equals. Now, a negative times a negative is a positive, so I'm not even going to worry about putting that into the calculator. 79,000 divided by 8.314. And now since I'm not using parentheses and the temperature is in the denominator, I'm going to press divide again. 298.15. Okay, and there we go. We get an E raised to 31.87 and a lot more decimals all, keep on going. Remember, don't round because this is not your final answer. We only like to round at the last answer, the final answer. So what I'm going to do here is I'm going to say second ln, that's the E button. See, there's an E there. And I'm just going to grab the whole number from the top, press enter, and there we go. Now I'll add the sig figs. There was 2 sig figs in my delta G. We used a lot for this Kelvin, so 2 sig figs, 6.9. And, I almost forgot about that times 10 to the 13th. So 6.9 times 10 to the 13th, and that's your final answer, a huge K value, but it makes sense because this is very spontaneous. So your K value should be way over 1. So it checks out. Okie dokie. I really hope this helped. Thank you so much for viewing the video. Check out the channel. We got many other subjects on there with more subjects on the way. All right. Love helping you guys out, and I hope you have a great day. Okay. Bye.